What we have here is a World War II aircraft receiver called named the BC-453B. This particular one was made by Western Electric in about 1942. It has 6 tubes. It's a super heterodyne. Tunes from 190 to 550 kilohertz, which is exactly covers the new 630 meter ham band. This particular receiver had been modified before I got it. Matter of fact, it had been modified for 12 volts filaments rather than 24 volt. And several other things had been done to it. It was missing its audio transformer and some other things. And I have put it back in operating condition. It's a very sensitive receiver at the moment, as a matter of fact. The loudspeaker I have on it is a Radio Shack CB speaker with a 500 ohm to 8 ohm transformer inside, so it matches the impedance of the receiver a little better. And the power supply is one I built from Radio Shack parts. It's got, what I've done is I've gotten two 12.6 volt center tapped at about 3.5 amp or 4 amp transformers, and I put them back to back so that there's 110 volts in one on the left side. It connects to the 12 volt winding to the one on the right side, and then the output of that one, which is actually the input of its transformer, goes to a voltage doubler circuit, which puts out at this point 230 volts, 6 volts, 0.9 volts DC when the receiver is operating. The filaments are, as I said, 12 volts AC. Now, at the moment, it's tuned to 550 kilohertz. Let's see if I can see this from here. There we go. Tuned to 550 kilohertz, and the signal that you're hearing is fed to it from my Hewlett-Packard 8640B signal generator, also tuned to 550 kilohertz. I have I'm feeding the signal at about a 1 microvolt level. Well, it's not focusing. There we go. And the meter is reading at exactly 1 microvolt output. And I'm feeding it a modulation of a 400 hertz, 30% modulated tone. Now, as you can hear, with no antenna connected and no noise, sorry, let me back up a little bit here. The receiver is doing quite well with 1 microvolt on AM. If we turn off the modulation and turn on the BFO, we could even reduce it to 0.3 of a microvolt, and we can still hear the signal. We go to 1/10 of a microvolt, and we can just barely hear the signal. So it's quite sensitive, and it's very, very selective. As an example, there is the CW or code beat note with a BFO on. As we tune lower in frequency, it just disappears. The other side of zero beat isn't even there, which indicates that this receiver is extremely selective. Now, these receivers work very, very well for use in the new 630 meter ham band. Now, let me show you a few other things. For instance, the way we have the power connected to this is through an old dynamotor base with the wires connected to that, as you see here. This is a base off of an old dynamotor. The wires from the power supply are connected to it, and this makes it possible to use these receivers without doing any really fancy modification of the power input and control systems. Now, when I first got this receiver, it had a very crude and not finished modification here. I've cleaned that up and replaced with newer parts. And let me show you what I've done to the bottom, so you'll get an idea of what one can do to these. Well, the ground popped off. That's the noise. I'll put the ground back on so we can get rid of the noise. There we go. And here you see what I've done to the bottom. The capacitors in these receivers are normally in cans, very similar to this. This is the audio transformer, or this is the BFO transformer. And the cans are quite large and take up an awful lot of room. When they were made in 1942 and after, they were had 3 capacitors sealed in each small can. I haven't got one here right now to show you. They were then filled full of beeswax. And the beeswax is mildly corrosive, and it reacts with the brass of the cans to form a verdigris-like substance, a green verdigris-like substance, which is conductive, and it ruins the capacitors. So those should all be replaced. Now I've replaced these, the old capacitors in this particular receiver with these. This is a 0.05 microfarad, 400 volt DC metal film capacitor. This receiver right now is working probably at least as well as it did when it was new. Inside the receiver there are intermediate frequency cans, IF cans, that look somewhat similar to this. This is out of a different receiver. But these have a rod that sticks out of this hole on the top here that you can pull up or push down to vary the coupling of the internal IF cans, and you can make it very, very selective by pulling them all up. The 3 IF cans in this one are all pulled up. Let's see, what else can I show you? All right, now I'm going to turn this off for now. Excuse me. There is a base plate, which I have not put on yet, which will go here with all necessary screws. The screws, by the way, are a 3 48 thread, a number 3 by 48 thread screw, and I'll put this base plate on before I use it. Now I'm going to turn this off for the moment, and then we're going to resume with when I connect an antenna and listen to some of the signals that are available now. It's still quite light here. I'm in Moscow, Idaho, and so the signals are pretty noisy, and my location here is noisy anyway. But we're going to try to pick up some of the NDBs and other things, other stations that are available on this band. So, a little later.